We are going to look at the parametric model, which involves concomitant variable. What is concomitant variable? Concomitant variables is variable that is observed in the study, but it is difficult to control. It is difficult to control as it is not the focus of the study. You may look at it as 2 or 3 competing risks, or maybe various causes of failure. It is common in clinical studies models to have concomitant variables. Some clinical studies take measurement of other characteristics that may be expected to have some associations with failure rates. For example, number of cigarettes smoked per day may be by itself contribute to failure or death. Another examples of concomitant variables may also be a symptom to the failure, such as high cholesterol level is usually considered as a risk factor in cardiovascular disease. Associations of concomitant variables to mortality may be distinguished but may not be quantifiable. Hence, the allowance can be made for it by the use of the select table. Let's look at an example. When constructing a select life tables for patients diagnosed with breast cancer, you may have primary variables and also concomitant variables. For this case, let's use time elapsed since diagnosis as the primary variable. And let's use age as concomitant variable. If you want to create another select life, you may also have another concomitant variables other than age, for examples. Let's use sex as in male or female. So with these different concomitant variables, you can already create 2 select life tables. Let's look at the general parametric models of hazard functions with observed concomitant variables. Let z prime equals to z1, z2, zs denote 1 times s vector of the concomitant variable. and let lambda t z be the hazard rate. Hazard rate also can be depending on some other parameters other than t and z. So let's assume that there is another parameters which is b prime as in a vector equals to b1 b2 bs. So in general we can say that lambda tz is equals to lambda tzb. For brevity, we are going to use lambda tz only. Here you can have more than 3 parameters. You can have more like b, p, and so on. Okay, but for brevity we are going to use lambda tz. So for this we are going to have the general hazard function, cumulative hazard function, this can be written as lambda tz equals to integration from 0 to t lambda uz du. And for this case, the survival function we can denote it as tz, which is also equals to exponential negative lambda tz. And for this case, the PDF will be the hazards times with the survival function. So you are going to get lambda tz times with s tz. Least square and also maximum likelihood methods are the most common methods used in determining their estimators. That's it for the introductions. Thank you.